Welcome back to another episode of Data Protection Gumbo. I am Demetrius, your host, and today we are going to have a great and exciting conversation around maximizing the performance and also usable capacity of NVMe. And you'll find out a lot later exactly what NVMe is. And if you don't know, then Kelley Osburn is definitely going to be able to explain that to you. He is the Senior Director of OEM and Channel Business Development at Graid Technology. So, Kelley, welcome to the Gumbo.
Thank you, Demetrius. I've been looking forward to joining your podcast for quite a while now. So I've been following it and have enjoyed many of your presentations and topics.
Thank you for taking time out of your day. Start us off by giving us a rundown of Graid Technology.
Sure, we're a company based in Santa Clara, California, and we set out to solve a problem that is facing most companies today when they purchase super fast flash storage known as NVMe, Non-Volatile Memory Express. So what's happening is the uptake or adoption of flash storage has increased to a much higher percentage of total sales of storage. And in addition to that, we're starting to see servers now that have much faster motherboards. So they talk about PCIe, for example, you might hear that. We're up to Gen 4 and 5 now. And so what that means is those drives are super, super fast. And we identified a problem in that the traditional ways that you protect that storage, most people have heard of things like RAID or Graid Technology, redundant array of inexpensive or independent disks. The traditional methods cannot keep up with the performance of flash. So think of a super highway and everything has to go down to a toll booth to get through to the application. And so that bottleneck or choke point is really what we set out to solve. So we're essentially a software company, and we wrote our own RAID stack that we deploy on an NVIDIA GPU, which accelerates it and solves that bottleneck problem.
Nice. And you mentioned the key word there. You said an NVIDIA GPU. So maybe we'll come back to that because that's the hot topic today, is all about these GPUs and how they are gaining, and people are looking forward to getting them, and they're expensive to get their hands on because AI technology is just hungry for that power.
Absolutely.
So let's start off with, so why does the world need a new RAID and data protection solution from your point of view, Kelley?
Sure. So as I mentioned, we're accelerating it to solve these well-known bottlenecks. But as you start to see, NVMe is changing in form factor. So if you look at traditional servers, when you had a hard disk that was plugged into a slot, that was a form factor of 2.5 or 3.5 inches. They would have a SAS or SATA connector. You plug them in. So when we first started doing flash, we just made drives that looked like hard drives so they could use those slots and use those interfaces. And now that we've moved to direct NVMe, the other thing that we're seeing is a much denser implementation of these drives. And you'll hear the term EDSFF. This is a term for an enterprise data storage form factor for NVMe drives. And what that does is it eliminates that 3.5 and 2.5 inch barrier, and it allows you to put a lot more drives in a server. So where before you might see a 1U Dell server, for example, might contain 12 drives, now we see 20. So the other factor is, in addition to the speed and density, it's the capacity. We've actually been working with some companies that are making 61 terabyte drives. So if you have 20 61 terabyte drives in a 1U server, and you have a lot of data there. So you have to have a better method to protect it. So we know this is the Data Protection Gumbo podcast, and the main factor here is protecting your data. That's our first and foremost. So we have things like write journaling features and all the kinds of things that you would expect to see, but we allow now companies to take advantage of that performance. When you buy that many drives with that much performance, the last thing you want to do is only get 5 or 10% utilization out of that. So we unlock that performance for applications like AI, ML, databases, et cetera.
And so you mentioned NVIDIA earlier, and you just rattled off AI and ML.
Yeah.
I want to get your perspective on a futuristic look. Like, where will we be, let's say 12 to 18 months from now, with the new Blackwell? I think that's the platform and the name of the new chip technology that NVIDIA is using, and you utilizing that in things like NVMe and data protection. Where are we going to be in the next 12 to 18 months with that technology and GPUs, et cetera?
We're really seeing a massive uptake of NVIDIA technology in general.
Mhm.
We're actually an NVIDIA Inception partner, so we're a developer to their platform.
Okay.
And I think the thing that a lot of people should realize is that it's an ecosystem. There are now 20,000 software companies writing applications that take advantage of GPU. And the reason for that is they're so much faster. And
Hmm.
so if you're going to do things like artificial intelligence and machine learning and neural network for various applications, speed is of the essence. So when you buy a super fast NVIDIA GPU or GPUs even from other companies, you've now faced a new problem. Just spent as much as $30,000-$40,000 on this GPU, or we're seeing servers that have 4 or 8 of them. How do I get the utilization out of those GPUs? How do I make sure that I can feed that beast? That's what we call it, getting the data to that quick enough so that I'm not, you know, sitting there waiting for data and causing an underutilization of those extremely expensive, purchases that we're making.
And you talked about RAID earlier, and RAID has been around for what, 3, 4, 5 decades? I mean, it's been a very long time.
Absolutely.
As long as I can remember RAID, I can remember starting my career back in 99, and RAID was already a well-known technology as far as being able to make sure you have redundant data and you can restore, and data is moved from one system to another, to a disk, one disk to another disk, and striping, and 1 plus 0 and 0 plus 1. And I mean, it gets
Mhm.
complicated, and I am still trying to figure out today all the different layouts of RAID. Why is RAID technology so important even today with this,
Yes.
technology?
Well, and as I mentioned, when you start to put 20 61 terabyte drives, or even we're running a test now with a server that holds 32 drives. If you do not protect that data, if you stripe across those to get the performance and create a large pool of capacity, if I don't have a way to protect that data, any one of those disks, if it fails or we have write errors or read errors, it could cause you to lose all that data, and now you have to restore that. The other problem is once you've got a scheme where you're protecting your data, an issue arises when and if you actually have a drive failure. How much time does it take to rebuild that drive? You have to
Mhm.
go read all that stripe parity information from all of those other disks, SSDs, NVMe drives, for example, and then recreate it, reconstitute it, and then repopulate that drive. And with today's large drives, the older technologies can take days and days and days. That means you're now vulnerable during a very large period of time to a second failure potentially.
Mhm.
And you're also most likely running in a degraded state where you're not achieving the performance that you would normally have out of that server because it's so busy reconstituting and rebuilding that drive. And so that's really another area that we set out to solve because G can do that so much more quickly than a CPU. We offload it from the CPU and use that NVIDIA CUDA core environment to redo all those mathematical calculations. So as you mentioned, RAID is fairly old, but yeah, the technology is using similar algorithms. We call them Reed-Solomon algorithms, where it,
Yeah.
it creates parity bits and stripes them, and you can use all those little pieces to recreate the data. And traditionally, what you'll see now is RAID 6 is pretty much the most utilized for this type of tech because it allows for 2 drive failures out of a set of maybe 6 or 8 drives, whereas RAID 5 would only allow for a 1 drive failure.
Now, is this something that someone needs to, let's say an architect, someone was architecting a storage solution for a certain workload and they wanted to achieve, let's say they had some databases, because it depends on the workload that you have that's running on whatever the different types of technology is. Is this something that an architect or someone has to really understand, or is there an easy way or an easy button that you can push to say, okay, I have these databases. I want to get the best read performance or write performance from these databases. Click this button and it'll go and set up the proper striping or RAID technology or whatever the disk capability is underneath it and do it. Is that something you've seen or not?
Yeah, there are lots of guides out there that'll help you calculate things like that.
So it's still manual though.
It can be. There are some
Okay.
ways to automate that. We're actually building APIs and UIs to help simplify things, but we do have
Ah.
a lot of documentation that helps explain it. In the good old days of spinning hard drives, which are still here,
Hmm.
but in that environment, a traditional hardware RAID controller will have things like caching. So they'll have memory on board, non-volatile memory. That therefore means you have to have batteries to protect that. If there was a power failure, you want to make sure that you don't lose what's in your cache. Because
Right.
if I tell an application that's on the disk, but it's actually in cache
Mm.
and I lose power, then I have a problem if I can't pick up where I left off when that power is restored.
Right.
So that that caching technology is very helpful to speed up the performance for writes, especially on hard drives. With NVMe, it actually would cause latency and introduce a reduction in performance. So in our environment, we don't have any caching at all on our card. We are using an off-the-shelf NVIDIA card, and we write straight down to the drive and acknowledge straight back to the application. So if there was a power outage and there's anything in flight, a write, a block of write going through the network, and if it wasn't down on disk, it'll know to pick up kind of where it left off. And then we have additional journaling features that can help in a recovery scenario like that.
Okay. So you mentioned striping, RAID, journaling. Are there any other data protection features that, let's say, someone who was architecting a storage solution that they need to make sure that they take advantage of?
Sure, if you depending on how much protection or we call it high availability you would like to have or need to have, you can do things like have 2 controllers, 2 of our products in your server,
Hmm.
and they can protect each other. So you would have potentially half of your flash on one and half of your flash on the other. And in the event of one of our controllers actually failing,
Hmm.
the remaining controller will automatically pick up the existing RAID groups and continue processing until you can schedule maintenance to replace that failed card. We don't see them fail very often, but we do offer that for extreme high availability environments. And no matter what, backing up your data on a regular basis is still best practice so that you have a copy of that data stored in another location for safety. Because if the whole data center crashes and catches on fire, you better make sure you have your data copied off, to another environment. So backups
Mm.
are still very, very relevant today.
And have you heard of deduplication before
Sure.
and the technology behind it? Are you still seeing people use and utilize deduplication? Okay.
Absolutely. To us, it's transparent because usually that's
Hmm.
happening before it writes to us. Or one of the things we're starting to see is what we call computational storage. So
Okay.
imagine an NVMe drive that has a chip on it, usually based on an ARM processor that will do compression, potentially deduplication, and even encryption
Hmm.
on the drive as it's writing the data. So we see that sometimes. A lot of storage arrays do deduplication as they're writing data, and that'll help you achieve, higher usable capacity out of your purchase.
And let's talk specific workloads and environments. So, if someone wanted to get the best performance, the best cost out of whatever storage solution or technology, which solution or what type of setup would they use? Let's say they have a mission critical application and maybe it's a proprietary system that someone custom wrote and designed, but it's all about getting information fast from it. So reading information fast, but not necessarily writing that data fast, but they need to definitely read it fast. And then also show it back to who's ever accessing it.
When you talk about overall performance, we don't improve the performance of it. What we
Hmm.
do is allow the performance of NVMe to make it to your application because it's not choking. So if you look at some of our, we call them hero numbers, the really super high performance numbers that we achieve, like over 200 gigabytes a second on a read, that had to be that was done by creating a RAID group over 24 extremely fast drives. So our card is capable of delivering that performance, but you have to have the correct number of disks behind it to actually create that read performance. So when you build an application like that, if you know you need 20 to 30 to 50 to 60 gig a second, the factor there is understanding how many disks you need to be able to achieve that when you create a volume across all those. And also, what's your overall capacity requirement? Those two factors come into play. And then adding in whatever overhead there is for RAID, you can back yourself into the solution of what you actually need to achieve that.
And everyone's talking cybersecurity and dealing with threats and things like ransomware, et cetera. Is there anything that can be done on the back end from where you sit from a storage perspective that can keep that data safe or at least minimize the damage that maybe something like ransomware can do?
A lot of that is occurring at an application layer where and so you can buy applications that will do things like create continuous snapshots of your data and other
Okay.
things so that if the corruption gets in there, you can have a rollback point to go back to a point in time. So
Hmm.
those are some of the technologies you can use. Other technologies and we're working with quite a few opportunities with the government and the military. In that type of an environment, you want to make sure that if someone gets physically a hold of one of your NVMe drives, that they can't read what's on it. So we
Okay.
take advantage of a technology there called a self-encrypting drive, where the drive
Okay.
itself cannot be utilized without the correct keys to unlock the data. So if someone stole that drive, they would plug it in and it would be a brick, right? So there's no
Yeah.
way to hack it. And we work with a number of the government agencies to fall under certain certifications for different levels of encryption that they need.
And so they need to make sure that their keys are stored somewhere else and
Yeah,
not in
you're
the
gonna have a
same
key
location.
manager, something like that. It gets even more interesting because when you have someone who can take a hard drive out of a server and plug it in and they can't read it, that's great. The
Hmm.
problem is, what if they get access to the whole server? So let's say we have an issue where an embassy is compromised and people have to leave and they leave behind equipment. And if someone
Yeah.
brings up that machine, all they have to do is hack into the OS and the keys are right there. And those keys get you into the data. So there are now technologies that are called pre-boot authentication,
Hmm.
which means you have to authenticate before it'll even bring the OS up. And if you can't boot the machine, the whole thing is a brick. And
Oh,
so it's a way to
nice.
protect, intelligence and important information from, falling into hands of people we don't want to have access to.
And before we close out here, maybe an opportunity for you to tell us what's on the roadmap for Supreme Raid and kind of what Grade is up to in the next 12 to 18 months.
Sure. And, I'm glad you mentioned that. Graid Technology is our company. Our product is Supreme RAID. It is a software RAID solution that's deployed on an NVIDIA GPU. We actually have and support multiple models of NVIDIA GPUs, and we only use very small GPUs from them. So we don't need a Blackwell or a Hopper to handle
Hmm.
handle the performance requirements. And so it's actually very cost effective. It's not, and we're also not in a environment where we have supply constraints for the GPUs that we use because they're readily available. So that's a good thing. We just recently released a version that's much less expensive and is designed for high-end workstations. So there are a lot of folks that are now doing artificial intelligence and AI on a desktop, and they still need super high performance. So they might have up to 8 NVMe drives in that high-end graphic workstation, or potentially a small server. So we just released a model that is lower cost that supports up to 8 drives. And then our regular models support up to 32. And in the future, we're adding things like support for the CSI interface, container storage interface with Kubernetes. We will be adding a user interface or graphical user interface and full API. We are also going to increase our drive support from 32 to 6 because we're starting to see bigger servers with more drive. And so constantly, we're also playing whack-a-mole with trying to keep up with all the different Linux distributions that we have to support. So every time we do a release, we'll come out with 4 or 5 more Linux distros because that's typically what we're seeing more of in this environment is Linux as opposed to Windows. But we do support Windows as well as Hyper-V. In terms of virtualization, we're working on VMware support. We have just released a new capability around Proxmox. So if you've heard of Proxmox, it's a new KVM-based hypervisor that people can use on a server to use instead of VMware or instead of using a proprietary hypervisor. So we're expanding our support for a lot of things like that.
It sounds very exciting. You mentioned CSI and Kubernetes. It's cloud native, and those are super fun things to work with. I've worked with those over the last 6 to 12 months, and Kubernetes and those cloud native workloads. That is some super amazing technology. So I am glad to hear that you guys are moving in that direction as well. And Kelley, I really appreciate the time that you've taken today to speak to the Data Protection Gumbo audience. And before I let you go, I want to put a plug in for the Backup and Recovery Professionals LinkedIn group. So I am not sure if you are already a member of that group or not, Kelley. So just type in Backup and Recovery Professionals on LinkedIn and request to join that group. There's almost 26,000 professionals in that group. So cybersecurity, storage, backup, recovery, and we're having great conversations similar to the ones that you and I are having right here on Data Protection Gumbo. So thank you again for taking time out and shedding some insight for us here on Data Protection Gumbo, Kelley.
Demetrius, thank you so much for your time today, and I'll definitely check out that group. I believe I'm already a member, but if not, I will certainly join for sure, and look forward to speaking with you again in the future.
All right. Well, Gumbo listeners, thank you so much. We appreciate you tuning in. And if you are watching on YouTube, please hit that thumbs up button and also share as well, because we are trying to grow the YouTube channel. And thank you, everyone. So make sure you stay secure and you back up often.